All right, welcome to The Explainer. Today, we're going to unpack an idea that pretty much turned everything we thought we knew about life completely on its head. And, it's still one of the most misunderstood concepts in all of modern science. Back in the 1970s, this was a super common reaction. I mean, can you imagine? Someone tells you a book claims genes have emotions? It sounds completely nuts, right? We'd all laugh. But what if that lunacy was actually just a powerful metaphor for a much, much deeper truth? Okay, let's get into it. Section 1. A revolutionary idea. When Richard Dawkins dropped the selfish gene back in 1976, this was not just another biology book. Oh no, this thing was a bombshell. It sent ripples across the entire world of science and even into our culture. The book became an instant classic. And as you can see, its influence just kept growing, decade after decade. It completely transformed whole fields of study and eventually gave us a brand new word for how ideas themselves spread through our culture. So, let's move on to Section 2, the gene's eye view. What exactly is this revolutionary perspective? Well, it's a simple but really profound shift in how we answer one big question. For whose benefit does evolution actually work? For the longest time, people just assumed that animals behave in ways that are for the good of the species. It kind of makes intuitive sense, but Dawkins argued that this was just plain wrong. Natural selection, he said, doesn't care about the species. It doesn't even care about the individual. The whole game is being played at the level of the gene. And that reframes, well, everything. Our bodies and the bodies of every living thing are just temporary vehicles. We're these incredible, complex survival machines built by our genes for one main reason, to help those genes survive and get into the next generation. Now, it is absolutely crucial to bust some myths here. That word, selfish, is just a metaphor. It doesn't mean our genes are sitting around plotting. And here's the really wild part. The book shows how this genetic selfishness is actually the foundation for altruism and cooperation. A gene that programs you to help your family can thrive because your family shares your genes. So by helping them, the gene is really just helping copies of itself. So gene selfishness is why we're kind to our relatives. So what exactly is a gene in this way of thinking? Well, think of it less like a blueprint and more like a really durable piece of information. You and I, we're temporary, but our genes, they can be immortal, functionally speaking, passed down from body to body for millions of years. And that incredible longevity is why the gene, not the individual, is the real unit of self-interest in the story of evolution. Okay, Section 3, biology through a new lens. This new way of looking at things wasn't just a cool thought experiment. It was like a key that suddenly unlocked puzzles in biology that had stumped scientists for ages. Let's take a look at the kakapo. It's this wonderfully weird, critically endangered parrot from New Zealand. And from a traditional evolutionary standpoint, this bird is, well, it's a walking contradiction. It's what you might call an intellectual affront, a creature that seems almost perfectly designed to fail. I mean, just think about this recipe for disaster. It's the world's biggest parrot, but it can't fly. The males do absolutely zero parenting. Instead, they hang out for months making this loud, booming sound that basically screams, "Hey, predators, free lunch over here," just as much as it says, "Hey, ladies." From that old good of the species perspective, this is a terrible, terrible strategy. It just makes you wonder, right? How on earth could natural selection produce something that seems so bent on its own destruction? If evolution is all about survival of the fittest, the kakapo looks like a blueprint for extinction. And here it is, the aha moment. The gene's eye view solves the whole puzzle. See, evolution has no foresight. It's just a constant competition between different strategies. And from the perspective of a male kakapo's genes, abandoning the kids to go try for more matings, as risky as it was a strategy that just happened to make more copies of itself than the safer strategy of being a good dad. The mate-a-lot genes simply won out over the parent-a-lot genes. Moving on to Section 4, the long reach of genes. The power of this idea didn't just stop with an animal's body. Dawkins later took it a step further, arguing that a gene's influence can stretch way beyond the creature it lives inside. This is where your mind really starts to bend. It's the idea of the extended phenotype. We usually think of a gene's effect, its phenotype, as something physical, like your eye color. But Dawkins said, nope, a gene's influence can literally extend out into the world. Think of a beaver's dam. That dam is just as much a product of its genes as its big, flat tail. Look at the caddisfly larva. It builds this incredible little suit of armor for itself out of pebbles and twigs. Now, that case isn't part of its body, but the instinct to build it is totally genetic. And the quality of that external armor directly affects whether the genes inside that larva get to survive. That case is part of the gene's survival toolkit. So if a gene is a replicator that builds bodies, Dawkins started wondering, is there a replicator for culture? And he proposed that there was. An idea that spreads not through DNA, but from one mind to another. He gave it a name, the meme. And the analogy is just brilliant. Think about it. Genes jump from body to body through reproduction. Well, memes jump from brain to brain through communication, imitation, and learning. A catchy song, a new fashion, a political idea. These are all memes fighting for space in our shared consciousness. All right, section 5, 30 years of impact. So all these decades later, what's the lasting legacy of this incredibly powerful idea? I think this quote really nails it. The book's power to completely rewire how you think about biology is just as strong today as it was back in 1976. It forces every new generation of students to really wrestle with the fundamental logic of life itself. The reason it's a classic is that it's so much more than a list of facts. It's a tool for thinking. It gives you a whole new framework that you can apply to almost anything in biology, forcing you to ask questions, argue with the ideas, and ultimately to think for yourself. And that's its true genius, the sheer range of it. This one single idea, this perspective of the replicator, creates a thread that connects the dots between the strange behavior of a parrot, the armor of an insect, and even the way ideas spread through our own culture. And that leaves us with one last, really provocative thought to chew on. If our genes built us to be effective survival machines, what are our memes doing? Are the ideas and beliefs that spread like wildfire through our society successful because they're true, or are they successful just because they're good at spreading?